Welcome back to our fourth and hopefully final video. I thought the third would be the last, but maybe not. So I have about three more questions to go over with you, one dealing with inverses, and you have a couple of examples for you to be able to do. So for inverses, remember, we convert this first over to y equals. And remember, we talked about inverses being simply switching your x's and y's. When we looked at it on a graph, it reflected over the y equals x line. So if we're going to switch our x's and y's, we switch these two, and we'll have x is equal to 2y plus 1. Then we're going to solve for y. When we solve for y, we subtract 1 to both sides. So I get x minus 1 is equal to 2y. To solve for y, I divide by 2, and y is equal to x minus 1 over 2. Or we write it as f to the negative 1, because that means the inverse of f of x is equal to x minus 1 over 2. Or another form that it could be written in, you could take that 2 and make both of them have a denominator and write it as 1/2 x minus 1/2. And that's what it would look like as a linear equation. Either one is appropriate. Look at your answer choices and let those be your guide as to how you need your answers to look. So we've got a few word problems. There's some work problems that are on your paper. Not sure how your teacher may have had you do work problems. When I show students how to do work problems, we make ourselves a quick little table. And in our work problem, they tell us that working together, Paul and Dan can pick 40 bushels of apples in 4.95 hours. Had he done it alone, it would have taken Dan 9 hours. Find how long it would take Paul to do it alone. So we're going to have in our chart Dan and Paul, and then we're going to have together. That's them working together. So what we're going to have is their rate, their time, and then I call it their job, because it's whatever that they're doing, and in this case it happens to be picking 40 bushels of apples. But that's not what we're concerned about, because every single time the job is going to be 1. So from the information that we know when they picked them together, it took them 4.95 hours. So when I fill in my chart, my time together is 4.95. And then I also know from my information that had he done it alone, Dan would have taken 9 hours. So for Dan, his time would have been 9. And then what I'm looking for is how long is it going to take Paul to do it. So I'm going to put an X in Paul's spot because that's what I'm looking for. Now we know if rate times time is equal to a job, and I wanted to solve for R, I would divide both sides by the time. So the rate is the job divided by the time. Or in this case, for Dan, Dan's rate is the job divided by the time. His job is 1, his time is 9. Together, their job is 1, their time is 4.95. And Paul alone, his job is 1, and his time is X. So this would give me my equation that I want to use, which would be Dan, which is 1/9, plus Paul, which is 1 over X, equals together, which is 1 over 4.95. Now to solve this, we could find our common denominator. If your teacher had you do common denominators, if they had you do the shortcut, that's perfectly fine, whichever way you did. I taught using a common denominator, and my students learn that they're going to multiply these two numbers together, and when you multiply those together, you get 44.55. So my common denominator is going to be 44.55x for each one of these. Now, what I had to multiply 9 by to get 44.55 was 4.95. So what that means is I'm going to multiply this by 4.95x. And what I do to the bottom, I must also multiply to the top. So my top will become 4.95x. For my x, what I had to multiply this by was 44.55. So I would multiply the bottom by 44.55 and the top by 44.55. And when I multiply that times 1, it's just 44.55. And lastly, 4.95, I had to multiply that by 9x to get 44.55x. And when I multiply 1 times 9x, I get 9x. Now, we went through a whole explanation of how once your denominators are the same, you could go ahead and add those and do some solving. But what happens is your whole denominator sort of disappears because it cancels out in the work of your arithmetic, and you end up with 4.95x plus 44.55 is equal to 9x. And so we can solve by subtracting 4.95x to both sides, which gives me 44.55 equals, when I subtract that over, that gives me 4.05x. I'm going to move up here so that it can all stay on the screen for you. So if I have 44.55 equals 4.05x, to solve, I'm going to divide by 4.05 to both sides, which gives me 11 hours. 11 hours for what? 11 hours for Paul if he were working alone. And that's what we would be looking for. That should help you to set up number 77 and 78, which are very similar to this problem. You just may have the x in a different spot, but the work is still the same. So give those a shot. Now, on these, looks like a whole lot more words, but it's not really as far as the equation is concerned. It's the information that they give us. They tell us that the force exerted by the wind of an airplane surface varies jointly. When you see that word varies jointly, that should be a big indication to you that these are easy, first off, and it's our basic formula, y equals kxz, where I'm going to be multiplying two things together. And this indicates it's fixing to tell me what those two things are. And when I see force exerted varies jointly, I want to start me an equation with force equals k times. And then it's going to give me my information that's going to follow that. It varies jointly with the square of the velocity of the wind. So the velocity squared, the square of the velocity, and the and tells me that's what I'm going to multiply. I'm going to multiply it by the area of the plane's surface. So the area. So I'm going to just use an A for area. Now all of my letters have meaning, and I can plug information into that. So using this, I'm going to solve for K. First, they tell me that the area of the surface is 40. So my area, A, is 40 square feet. So in place of A, I can put a 40. And the wind velocity is 20. So my V is going to be 20. And I'm going to square that 20. And multiply it times K. And they tell me that the resulting force is 15 pounds. The resulting force is 15 pounds. So I know I'm going to have a, I'm going to be blue again, sorry. I want my 15 to go here. Now we first need to solve for K. In order to solve for K, I can multiply these together. I can use my calculator. go back to my calculate screen, and I'm going to do 20 squared, whoops, helps if I hit the buttons right, 20 squared, and I'm going to multiply that by 40. Oops, sorry, I hit an extra letter. 20 squared times 40. Make sure I typed it in right, enter, and that gives me 16,000. So I know that 15 equals K times 16,000. Whoops, lost a zero. With my 16,000, I can divide both sides by 16,000. When I divide, I'm going to have 15 divided by 6. You can either type in the 16,000 or you can do the control answer and it'll do the same thing. And it gives me a fraction. If you don't like the fraction, you can do control enter and it will turn it into a decimal for you. So we are approximately, whoops, sorry it went off the screen for you, but it was 0.0009375, and that's approximately K. Now, I still have that number on my calculator. I'm not going to delete it. When I go back to my calculator, you'll see it's still there because we're going to use that in our formula. Our formula is F equals 0.0009375. You don't have to write them all. I just, as habit, do that. We know the velocity squared times our A. So now the next sentence is going to give me more information about these three things. They tell us that the force on a surface is 65 square feet. So that 65 square feet is an area. So that I'm going to plug in 65 right there. And they tell us that we have a velocity of 30 miles per hour. So my V is my 30, which I have to square. And notice it says find the force. So I'm looking for F, and all of this is still the same. So I want to just plug that into my calculator. So when I pull up my calculator, this was my decimal that I have right here. So I can simply say times, and then I'm going to plug it in parentheses just because I like it to look the same as it does on my paper. So I'm going to have that squared, and then I'm going to multiply that times 65, and then I make sure it looks the same as it does on there, and push enter, and I get that my F is approximately 54.844 pounds. Pounds because we're talking about force, and that's what they told us to use. So 54.844, and I rounded that to 44. Okay, and that gives you your final answer. So look for those varies jointly. I don't think on your exam, since our review, notice on the review, the other three problems are all varies jointly, varies jointly, varies jointly, which is probably a good indication that on your test, you're going to see varies jointly, varies jointly, varies jointly. Okay? Oh. And it looks like that is the last one that I have for you to see. So hopefully this helps you. If you have questions, please feel free to come and see me. I'm Mrs. Peltier, or you can come and see any of the other Algebra 2 teachers, Mrs. Blatt, Mr. Cleland, Miss Marino, or Mr. Ruff, and go and get some help. Make sure that you're ready for your exam, and good luck. Have a great day.